Good evening, everyone. I'll be going through the code and the algorithm that were used, and I'll be giving a brief introduction, which brief info about what are the things that I use for the, predicting the credit card fraud detection, and what is the strategy that I followed, and everything. The strategy that I followed is like first I'll be finding the best features of from the data, and then I'll be splitting the data into testing and training data, and I'll be using I've used Gaussian knife-based model algorithm where we can train the model using the cross validation technique, and then we'll be classifying the transaction in the test data. So the required models that have been imported are NumPy, Pandas, Matplotlib, and Seaborn. But NumPy is used for, as I told, I'll be using Gaussian knife-based algorithm, so I can import from the NumPy as well, using NumPy. But I'll be importing from the sklearn knife-based module, where Matplotlib used for plotting pie charts on a few charts. Whereas Seaborn is something which will be going through as like it is in a histogrammic way of representation where we can see the overlapping of best features and bad features, where you can classify whether is there a fraudulent detection and so on. And and the pandas which are well known for reading CSV files and creating data frames and reading from the data frames. So how do we say that whether it is how do we detect whether it is a credit card is in a fraud or and a good one? So when we say it is in a good it's not in a fraudulent credit card edition when the class is 0. So when the class is 1, we say that credit card is in a fraudulent detection. So here I plotted the pie chart which represents the genuine transaction and the fraudulent transactions, where you can see that the 492 transaction and the fraudulent transaction. I just there are precise ones we can't say the exact 492 from the data which we have. There are the precise 492 transactions with the fraudulent transactions, and and where next what I've done is we know there are the three there are filter methods like wrapper method and embedded method. Where the filter method, what we do is first we select all the features and selecting the best subset feature, and we uh, embed the algorithm, and we check the performance of the data or the data which get the output which we get from the output that which we get. And and where where you can see that from the features that I have plotted using Seaborn, um, where you can see that there are V13 V15 there is some overlap, so where we can say that these are the fraudulent transactions. And when you compare from V1 V2 V5, there are no much overlap, so there is no much overfitting. So we could say that there is no much overfitting. So we can exclude these features because when when we send these when the complex features are sent through an algorithm that makes sophisticated, so that the algorithm cannot perform, we can't get at the precise result that we expect. And I've done a cross validation using Gaussian knife-based algorithm. So let me give you a brief overview of what is Gaussian knife-based algorithm, where we are most of us are familiar with the Bayes theorem. Bayes is something that where we have an equation. The expression is uh, probability of A given to B is equal to probability of B given to A times of probability of A divided by probability of B. Where here what we say is probability of probability of A is nothing but the probability of hypothesis, and probability of B is not something the probability of the data which we have. So when we say that when we have the maximum probability of hypothesis or maximum is we exclude the probability of uh, the data because it's in a constant, so it doesn't much affect the maximum probability of the hypothesis. And the knife based algorithm is nothing but like it classifies the algorithm for binary and multi-classes algorithms, and the frequency of specific classes are divided total number of instances. And let me give an example, like we have a countries like France and France and Germany, and we have a class which is something we tell is a genuine or fraud. So where the categorical inputs are knife based and real valued inputs are the Gaussian knife based. And like what is the programming logic? Logic is quite simple. That I told I use this class from the this function from the sklearn knife base. And yeah, yes, this is a confusion matrix. The confusion matrix which gives us a precise understanding of the credit card fraud detection. Um, let me tell you what is the confusion matrix. Like confusion matrix, we generally have a matrix representation of actual classes and the fraud classes, where you can say that genuine is an actual class and fraud is an a predicted class, that the thing that we can predict it. So when here like the important things that to be noted is the accuracy, precision and recall. Before going to this, let me given how do we calculate this accuracy, precision and recall. So generally we have this value like 5634. Generally we call it as a true positive value. So how do we say it is a true positive value? That true is something which we observe from the data. So if the observation is positive and the predicted value is a positive, we say it's a true positive. And the false positive is something, but when the observation is negative and the prediction is also negative, then we say that there is a false positive. So this is how the parameters lies. And how do we find these accuracy and precision and recall is? The accuracy is something nothing but the sum of true positive plus a true negative divided by sum of all the parameters like true positive, true negative plus false positive plus false negative. And whereas recall is something similar, a true positive divided by true positive plus false negative, where precision is simple, a true positive divided by true positive plus false positive. But let me give an a known, you should know that we shouldn't just put these values in a formula where we need to understand like what these equations tell. Where in this confusion matrix where we have n by n, like that is 2 by 2, so there might be a larger confusion matrix. So in those confusion matrix we need to sum the values n times, the true positive values, the true negative values, so that we'll be having a precise understanding like what is like what it is showing. And this is how the complete I'm not going through the complete code which might confuse you. So the topics on the strategy and what are the things, what are the model that I've used for finding this credit card fraud detection and fraudulent transaction, this is what I've used. Thank you.